Today we're going to talk about rate of change. Rate of change is just an add-on to something that we've already learned before, so it shouldn't be too challenging for you to try to figure out. So I'm going to go ahead and I'm going to highlight my title, and then I'm going to highlight where it says, when you hear the word slope, what do you think? I want you to pause this video, and I want you to take 30 seconds, and I want you to write down everything you can think of when you hear the word slope. When you finish, unpause it and we'll go over it. So when you hear the word slope, you should first off think that it's the slant of a line. Slant of a line. You should hopefully also think of the variable, which is m. Hopefully you should also think of rise over run. And last but not least, you should think of the formula, y1 minus y2 over x1 minus x2. If you hear the word slope, you should always think of four things. So now if you look at the next question, it says, what is the technical definition of slope? The technical definition is the change in y over the change in x. So the slope is just taking my y values and determining its change, and then dividing it by the change in the x values. So we reviewed slope because the word rate of change is just a fancy word for slope. Rate of change is a fancy word for slope. It is the dependent variable divided by the independent variable. So if we take a look at this and we talk about the difference between independent and dependent, hopefully those words look familiar to you because you learned them in science. Independent variable, it is the value, or I'll say the variable that changes. And the dependent variable is the outcome. So I'm taking my outcome, the rate of change, and I'm dividing it by my variable that changes. So if we now relate independent and dependent to variables, do you think independent is x or y? Well, it's x, because x is the one that changes. I pick my values for x. And dependent is y, because when I plug in x, I get y. Okay? So if I go ahead and I start looking at some of these problems, it says Jane is driving in North Carolina and notices that at 2 hours she's traveled 80 miles, and at 6 hours she's traveled 240 miles. Determine Jane's rate of change. So I see this word, rate of change, and I just say, hey, that just means slope. So to help my brain, I'm going to make a table of x values and y values. X values are the numbers that are changing, and y values are the outcome. So my value that's changing is 2 hours. She goes 80 miles. And at 6 hours, she goes 240 miles. And if I put parentheses around these, notice I have two ordered pairs. So if I'm determining the slope, how do I determine the ordered pair? How do I determine the slope from ordered pairs? I do the formula. y1 minus y2 over x1 minus x2. So y1 is 80 minus y2 is 240 all over x1 is 2 minus x2, which is 6. So I'm now going to do what 80 minus 240 is. So 80 minus 240 is negative 160 divided by 2 minus 6 is negative 4. So I get 40. So 40 is my rate of change. So 40 hours per mile is my rate of change because it's, it's not hours per mile, it's miles per hour because it's y divided by x. Another piece of advice is whenever you're determining which value is x and which value is y, if you're having a hard time determining which is x and which is y, a friendly hint is x is always time. X is always time. years, months, minutes, hours, those are all time, so that's just always what x is going to be. So if I go ahead and I look at example 2, it says at 30 seconds on a run, Joe's 500 meters away, and at 50 seconds, he's 700 meters away. Determine Joe's rate of change. So I see the word rate of change, and I instantly go, hey, that means slope. So I'm going to set up a table when I'm doing rate of change, and I remember x is always time. So what's it going to be, 30 seconds or 500 meters? It's going to be 30 seconds because that's time. He's 500 meters away. That's the outcome. And at 50 seconds, he's 700 meters away. And if I put parentheses around these and a comma between them, they look like wonderful ordered pairs. So determine Joe's rate of change. So to determine the slope, all I do is y1 minus y2 over x1 minus x2. So 500 minus 700 is negative 200. Divided by 30 minus 50 is negative 20. So that equals 10. So I'm now going to put it into context of the problem. So it's y divided by x. So my y values represented meters divided by my x values, which were seconds. So my average rate of change is 10 meters per second. So with this knowledge, I want you to try example 3 and example 4 on your own. When you finish example 3 and example 4, please bring it to me so I can check it.